Hey guys, so today we're going to be reviewing what you should have learned last week, Thursday and Friday. Thank you to those of you who pushed through and put all of your effort when I wasn't there. I really appreciate that. But like I said, we're just going to review for your quiz that you're taking later today. Alright, so we're just going to go through and answer the question, make sure that you're writing as I'm writing. Alright, so this is asking which of the below elements have both metallic and non-metallic properties. Alright, because we are now in chemistry, our little chemistry unit to get you prepared for next year, your best friend is going to be your periodic table. Alright, so we know that metals are on the left of the zigzag line and nonmetals are on the right. Anything that touches this zigzag line is going to be a metalloid, which has both metallic and nonmetallic properties, which is what this is asking. The fact that it says "and" means that the element that they are looking for is a metalloid, which means that I'm looking for an element that is touching this zigzag line. The one that's doing that is silicon, or Si. Next, which element is classified as a nonmetal? So nonmetals are to the right of the zigzag line, so that means up here. The only one that fits that is chlorine. I'm going to go through how we fill this out. Alright, so speaking of chlorine, alright, we're going to determine all of these attributes of it. So the group number. Remember, groups are just columns. If I look, I find chlorine, and then its group is either 17 or 7A. So you could write either one of those, 17 or 7A. The period are the rows. So it's in, if I count 1, 2, 3, it's in period 3. The atomic number is the number that's on top here, which is 17, and the mass number is what's written right below the symbol. That's the Cl, and I always round to the tens decimal place, or the hundredths decimal place, sorry. So it's 35.45. Alright, the valence electrons are electrons on the outermost shell of when we draw an atom. We can predict those for any element that's in a column that has an A next to it. Okay, so there are 8 columns, 1, 2, 3, 4, 5, 6, 7, 8, that all are labeled with A's. Chlorine is in a group with 7A. That means that it has 7 valence electrons. Now my atomic number always tells me the number of protons, and I know in an atom the number of protons and the number of electrons are always equal, so electrons are also going to be 17. Neutrons I just determined by doing the mass minus the protons. So protons and neutrons are the only things that have mass, so we add those together to get the mass. So the mass in this case was 35 minus 17, and that gives us 18 neutrons. Let's move down. So the new information today is talking about Bohr models. This is how we visualize atoms. So all matter is made up of atoms, literally everything. So the table that you're sitting at, the marker that you're using, you yourself, you are all made of atoms. But what is an atom made up of? Well, we call those subatomic particles. So sub meaning below, atomic, and atom, things that make up an atom. Subatomic particles are protons, neutrons, and electrons. So there's a couple of information that we're going to go over. So namely the charge. Protons, pro, positive. Neutron is just neutral. There's no charge. It's just neutral. Electrons are negative. Think like electron, like electricity. Being struck by electricity is kind of a negative experience. I wouldn't try that at home. The location is in the nucleus, or the center of an atom. And then the electrons they're like in an electron cloud or outside the nucleus. Alright, mass, protons and neutrons each have a mass of 1, and electrons have no mass. Alright, one way, it's not the only way, but one way that we can visualize an atom is through a Bohr model. So there's literally this guy who's named Bohr, created the Bohr model. I know, how classy, he named it after himself. Okay, each energy level, which we're going to visualize with rings, can hold a different number of electrons. And we can use this equation, 2n squared, to determine how many electrons each hold, and just representing the energy level. Energy levels are really just the periods. That's it. Okay, So if I plug this in, this first energy level is going to only be able to hold 2 electrons, and the second one's going to be able to hold 8. Third is going to be, we're just going to say 8 for now. Okay, if you're plugging this in and you don't see this make sense, you can talk about it later with me. All right, flip your page. All right, steps for making a Bohr model. We are determining the number of electrons, protons, and neutrons. Okay, we are going to place the electrons on the rings, and each orbital ring must be filled to move on to the next one. All right, so step 1, determine electrons, protons, neutrons. All right, if I find carbon on my handy dandy periodic table, I see carbon. I see it has an atomic number of 6. That will tell me my protons and my electrons because they're always the same. Neutrons I determine by the mass, which is 12, minus the number of protons, which is 6. Therefore, I get 6 neutrons. Hopefully this isn't an unlucky atom. If you're superstitious, I'm very sorry. All right, so I know based on my table on the last page that my protons go in the center and my neutrons go in the center. I have 6 protons, 6 neutrons. All right, my electrons go on the outside. They're going to go on these rings. We always fill this in from the inside out. All right, so I know I can write this like 2, 8, 8. So my first row, second row, third row. Okay, my first row is only going to have 2 electrons, so I can fill in 1, 2. I fill it in pairs to begin with. And then my second ring is going to have, it has a max of 8 electrons. I need to make sure that I have 6. So I've already used 2. That means that I have 4 left. So I'm going to start filling in. 1, 2. First 2 are paired. I can put them anywhere that they have to be paired. And then 3, and then 4. Okay, so then I just put 4. That means I have 0 left. So I've used all of them. I want to get back to this word valence. So valence means outermost electrons. So if I see on my last ring I have 1, 2, 3, 4. Each dot represents an electron. I have 4 electrons on my outermost ring. If I found carbon in my periodic table, it's in group 4A, meaning it has 4 valence electrons, and that matches. Yay for us. You are going to try these 2 Bohr models and then get ready to practice these as a little review to get ready for your quiz that we'll take at the end of class. Get started and have fun with your new best friend, the periodic table.